In today's lesson, we're going to look at a two-tailed hypothesis test. So far, you've been doing one-tailed hypothesis tests, and we saw this in the alternate hypothesis, where we set the alternate either greater than a probability value or less than a probability value. And we determined that based on some of the wording in the question. We were looking for phrases like increase or decrease, for improve or reduce, more likely and less likely. Each of these phrases indicated a direction, either to be greater than or to be less than. We're now going to look at cases where that direction is not indicated in the question, where we're told there's a change, but we're not told what direction that change is going to be in. Let's have a look at an example. So here in this question, we're told that past records from a large supermarket show 40% of people who shop there choose to buy a tote bag. Okay, I'm just going to highlight some of the important parts of the question. So the 40%, that's the probability that a customer buys this particular type of bag. The manager actually wants to rearrange the store, and he moves the bags to a new location and wants to see whether this has changed the proportion of customers who are going to buy the bags. So here, we're checking for a change. We haven't been asked to check for an increase or a decrease, but simply a change. On a particular day, a random sample of 30 customers who visited the shop was taken. So this is going to be the size of the sample, 30, and we're told 16 of them were found to have bought a tote bag. So 16 of them bought the bag. Here's all the important parts. We can start on the hypothesis test. As usual, let's just clarify. X, so the random variable, is the number of customers who buy a tote bag, whereas P is the probability that an individual customer is going to buy a bag. This leads to our distribution, so X follows a binomial distribution where N is 30 and P is 0.4. So as in, the number of customers who buy a tote bag can be modeled with a binomial distribution, and in this case we had 30 customers and the probability any one of them bought a bag was 0.4. This is our shorthand for that statement. So let's get to our hypotheses. The null hypothesis is that P equals 0.4. Everything is how it used to be. This is the status quo. The alternate hypothesis, and this is how we write it, that the probability is not equal to 0.4. Maybe it's more, maybe it's less. Those two situations together can be described as not equal to. So that's the first difference in the hypothesis test process. Secondly, the significance level, the 5%, we're going to divide that by 2. So we'll write alpha over 2 equals 0.05 over 2 equals 0.025. So this is 2.5%. And we're going to apply 2.5% for the case where P is less than 0.4 and 2.5% for the case where P is greater than 0.4. You have to do this dividing by 2. A lot of students forget to do this, and at the end of the hypothesis test, they're making the wrong comparison. This is part of the process. Make sure you write this down. Back to familiar territory, we're going to calculate the expectation. In this case, it's 12. We can put that onto our diagram, and we know that we saw 16 customers on this occasion buy the bag. So we can put the 16 on the diagram, and we're looking for this region off to the right-hand side. What is the probability of this blue shaded area? That's going to be our p-value. That's the value we're going to make a comparison with. So into our calculators, we're going to check for the probability x is greater than or equal to 16, and this is 0.0481. We're making the comparison with 2.5%. 0.0481 is larger than 2.5%. Is larger than 0.025. This is not a significant result. We would need the probability to be small, relatively and significantly small. If you notice, students who hadn't divided by 2 would get a different conclusion here. They would think that this was smaller than 5%, which is written in the question, but we should be making our comparison with 2.5%. Don't be one of those. The rest of the hypothesis test is, as you're familiar with, we're going to make our two conclusions. We do not have enough evidence to reject H0, and in context, we do not have enough evidence that the proportion of customers buying a tote bag has changed. So the main differences in the hypothesis test happen early on, the alternate hypothesis and splitting the significance level in two. If you get those bits correct, the two-tailed test will follow through for you.